Welcome back, folks. Today I'm going to talk to you about buck converters or VRMs, what they're made of. I'll show you them on the board and I'm going to show you how they work. So we're going to go to the microscope now, and I have the same motherboard I had yesterday. It is currently plugged in, and I will show you that currently, while it is not on, I'm going to stick one of my leads on ground, and then I'm going to put another lead at my voltage in. I guess first I have to turn on my voltmeter, and I'm getting 19.47 volts. Okay, 19.47 volts, somewhere in that range. Most laptops run on about 19 volts. Let me show you that. There we go. 19.47. Okay. Now, drawing your attention to the microscope, this right here is a MOSFET. And a MOSFET is essentially a transistor. And so a transistor, you know, has three legs. Well, a MOSFET has three parts. This part right here is the gate, then these three pins are the source, and then these over here are the drain. This is where the voltage comes out. The gate is where it receives voltage and it's told to turn on or off. Now, let's go ahead and take a reading from the gate, and with the computer off, it is nothing. Okay, it's zero. So let's turn this computer on. Yesterday I talked about voltage states. We had S3, S5, and SO. SO are voltages that are present when the system is on. So that's state or status on. And so they won't be present unless the device is turned on. Let me get this turned on for you real quick, if I can remember where that was at. Come on, where are you? Oh, here we go. Okay, as you can see, there's a blue light on the computer, on the motherboard. We're going to go right back to that same spot. Okay, now this is located near the V-core. We're right here at the processor. Okay, so this is a V-core buck converter, and on this computer there's only two. So I'm going to stick my negative probe, get it stuck somewhere so I have a free hand. Hopefully that'll stick in there and give us good reading. And I'm going to point my probe at the gate, which is right here, and it's reading 4.62, 4.61 volts. Okay, that's what it's reading at the gate. That means turn on, and actually it's sending that signal. Here we go. What did my negative? Let's get that going again. Okay, 4.61. Now over here on the drain, I can pick any one of these pins. It is now reading 1.09. So a MOSFET is lowering voltage and raising amps. And it goes from here, the 1.09, to here. And right there, we're reading 1.09. And then it goes to either one or more capacitors, and in this case it's two large capacitors, this one and this one right here. Those are polarized capacitors. So that's essentially how things are powered on a motherboard. I'm going to go ahead and turn off my multimeter, and it is time for a little bit of a beer break. So we're going to have a beer. You can see we're a little bit into the drinking beer. Now this next part, I'm going to take the board away, so I'm going to unplug it and set the board aside. And I am going to draw out for you what this is, and I'm going to show you what a MOSFET looks like. So I'm going to raise up my microscope so I can write. And I'm going to get it focused in on my writing. Clear this area. Okay, so I'll grab a pen and I'm just going to write and let's see. Okay, that's fairly focused, but we're going to have to get it a little more focused. Okay, so right here I'm going to draw a MOSFET. All right. Why is it going wonky? Why is it wonky? Oh, it's because of my, just a second. So we're going to draw a MOSFET, and essentially it is a square IC. Okay, on one side you've got 4 prongs, and on the other side you have 4 prongs. Love my artwork. Okay, and we're going to call this first prong right here is going to be the gate. Let's lift up a little bit so you can see. Okay, so that first prong right there is the gate. And to show you, I'm going to show an actual MOSFET, the back side of it. Okay, there's an actual MOSFET. And that, you see how this is separate right there? That is the gate, and this is the source. This part right here is just a pad to get it to stay on the board, and then these 4 pins here are the drain. That's what a MOSFET looks like. Okay, and there's tons of them on a motherboard because that's how they control voltages, and in the case of high amp devices, that's how they control raising up the amperage. Now your MOSFET is going to feed directly into a coil, and the symbol for a coil is like this. And what do they actually look like? Well, they look like this or any variation of that. Some of them that's on the older computers actually have the coil showing. The back side is just the 2 in, out, and it doesn't matter because this is not polarized. It can go either way. Now, inductors or coils are measured in henries, but on a schematic you'll read it as an L. Okay? So on a schematic, an L means a conductor or a coil. But they're actually measured in henries, and most of them are going to be micro henries. Okay? Now, when a conductor can never cause a short, but it can go bad. And to figure out how the value of your conductor, well, the best thing is if you can read what's on the top. okay, and then find a matching conductor. But I'm going to show you the formula for figuring inductance is actually a little bit backwards. What you're going to solve for is resistance. So your formula is R equals 2 times pi, and I forget the symbol of pi, so I'll just pi times frequency times inductance. Okay? So, all you need to do to figure out the value of that is to measure the resistance on it. So if you measure the resistance on it, well then you have the inductance. Okay, you're kind of doing it backwards. You're going to figure out how many henries that is. So you don't necessarily have to get an LCR for an inductor. I do recommend an LCR or an LCR function on your multimeter so you can measure capacitors. Now then, this coil has properties to it, measured in henries, okay? And this coil, with whatever properties it has, it's going to take the signal from the MOSFET, which is actually turning on and off about 600,000 per second. Okay, about 600,000 times per second. Let's write that again down here a little clearer. 600,000, that's the average, per second. And that's the great thing about MOSFETs is because they can be turned on and off so quickly. Your multimeter can't pick that up. You have to use an oscilloscope. Now I do have an oscilloscope, but you get my point, okay? And then the signal that's coming out looks something like this. So let's see, I'm gonna draw like this. So it starts at nothing and then goes up to its peak voltage and then back down to 0, then off a little bit, whoops, off a little bit, and then on, I should have used a different pen, down to 0, on, down to 0, on, and that's what on an oscilloscope your signal is going to look like. But it's going to be on more than it's off. Okay? Now, that signal gets immediately sent to this inductor. And one of the reasons that it has to be so rapid, so quick, is this coil gets magnetized very quickly. And you want to avoid that unless you're doing it on purpose. Because when it becomes magnetized, okay, remember in elementary school, here, let's go down here. Here's our coil. If it becomes, magnetized, okay, all right, it then begins to act like a capacitor. It becomes this, okay, and then it becomes a power source, like a battery. So your inductors on your board can be looked at, well, it's cutting down voltage, but it's also a source of power. And in some schematics, your inductors actually are used probably several thousand times per second as a battery. It's sending the voltage because when that electrical field collapses back down to nothing, it turns back into DC voltage. It is going to pass voltage and current. Okay, so That is how most computers or laptops are operated. Now on a regular laptop or a regular desktop, you have a power supply that does most of this. And you look at a gaming desktop motherboard and you hardly see any MOSFETs and coil combinations except for around the processor. Well, that's because the processor is hungry, and gaming machines have got a lot of them. But otherwise, your power supply is doing all this divvying up of voltages, but you don't have that leisure to have a full power supply in a laptop, so it needs to be done within the circuit itself. So let's take a look again. Let's get that out of the way. And let's look at our board again. That's not our board. This is our board. Oh, yeah, this is our board. Okay, just taking a look. Look where inductors start right at the beginning. That's right near the power supply. And in fact, on the opposite side of the board, I suspect, yep, right here, you're going to run into MOSFETs right away, okay? Those are the inrush MOSFETs. And then, so it starts right at the very beginning. And then you've got the two here on the V-core. Then you've got another one over here. And if you look wherever there's an inductor, you're going to find a MOSFET. Okay. There's another inductor, capacitor. Now your capacitors can be these round aluminum covered. Let's get that focused a little bit better. I think that's better, yeah. Round aluminum covered ones, or they can be the black ones that are polarized, or they can be the small SMD type. They are all capacitors, okay? And if the inductor, or if the MOSFET isn't on that side of the board, well, you can pretty much count on the other side, it's right there. Hang on a second, let me get to it. It's right there, okay? So wherever you see inductors in proximity, there will be a MOSFET. And then of course there's a chip, and then the chips that control the MOSFETs are actually smaller than the MOSFETs. So guys, that's how power is delivered in your computer. It's mainly through MOSFETs, inductors, and capacitors. MOSFET lowering the voltage and raising the amperage, the inductor further cutting down the voltage, sometimes acting like a battery, and then the capacitor is smoothing out the electricity so it's nice and smooth. Okay guys, this was a short one. I lost my train of thought. Oh yeah, my hair. My hair is standing very tall today, and so today I'm using a very special hair treatment. Now you guys have all heard me say that I have a difficult time finding oil-based pomades. Well, one of the things that you can do if you want an oil-based pomade or oil-based hair treatment, because the nice thing about that is they don't dry out. Well, you can just go right in the fridge and grab some butter. That's what I'm wearing right now. This is straight up butter. Not only is my hair nice and soft right now, and I can comb it any way I want, it also smells like lunch. And just just like that other pomade that I told you that smelled like cologne, and women were always just all over me. I had to beat them off of me like with a stick. Well, women get hungry too. So that's another advantage of using butter. Now you will have to rinse it out every now and then, 2 or 3 times a day, because it will get rancid. Hey guys, thanks for watching. Please subscribe to my channel. We'll continue on this journey, learning tips and tricks. Have a good day.